Hello viewers, my name's Alan and welcome back to my home workshop. Today's project comes about because we need to replace this cheap Chinese PoE PTZ surveillance camera which has failed with something which is a bit more robust and reliable. That, hopefully. So the project today though is working out how to adapt the new camera to fit the mounting that was created for the old one. So as you can see, whilst the two cameras are very similar in concept and configuration, the size is quite different. The new camera is somewhat larger than the old, and that carries forward to a big difference in the mounting arm as well, which we'll have a look at. So you can clearly see that and not surprisingly, that the mounting arm for the new camera is quite a bit more substantial than the mounting bracket for the old one. And that creates a bit of an issue because the bolt pattern is quite different. And therefore the junction box that the old one was bolted onto clearly needs to be modified. So this is the old junction box, and this might go out of focus, but we'll see. Oh, okay. So clearly that's how the old arm mounted on. The new one is a lot bigger. We're going like that. Now when the old one was on, being so much smaller, it didn't cover the screw holes for that fixed the lid of the junction box. But the new one, being so much larger, it misses the four corner ones, but it covers the two middle ones. So I need a different way of mounting this. And what I decided to do was put these riv nuts in, so I could put the lid on first, including the middle screw, and then attach this afterwards. Now when I measured it all up, I noted that the rubber gasket underneath the new mounting arm protrudes by about 2.5 millimeters from the base of the bracket, and the exposed face of these riv nuts is 2 millimeters. So I was thinking that I might get away with it and that have 0.5 millimeter of compression on the gasket. But I've decided that's playing with fire because the rubber might shrink over time or whatever. So what I've decided to do instead is to relieve the underside of the holes to give clearance for the outer face of the riv nuts, so then when I do the screw up there won't be any limitation on how much clamping pressure goes on that gasket. As an aside, one other issue I'll have to deal with is that's the gasket for the sealing the back of the new bracket to its mounting face, and the holes that mounted the original bracket are outside of that, so I'll have to find some way of filling those holes, ideally in a way which is very minimally, if at all, protrudes above this surface, because otherwise I'll have an issue with the back of the bracket on those. Anyway, so the issue today is all about how to mount this in a milling machine so I can relieve the undersides of these holes. Okay, so this is the fixture I came up with for holding this bracket, and as you can see it's basically two angle plates bolted together so that the upper plate creates a flat surface that I can bolt the camera bracket to, and it'll become a bit clearer when you see the camera bracket bolted in there. It's a bit rude and crude, but I only had to do the job once and it was good enough for that. Okay, so check that the plate here set up level. That's all right. we're happy with that. Okay, now I've got the plate level in the horizontal plane, I've got to get it square in the Y plane. So I've set the dial gauge to 0. It's not that far off, but obviously it needs a good tweak, so we'll oblige by giving it that. So it's got to come away from the dial gauge a bit. Might give that a try. I'll just nip that a bit and see how that looks. Well, I'll take that as good enough for this exercise. Okay, so my plan, now I've got this running square or parallel to the y-axis and horizontal, is to mount this underneath like that, 2 bolts at the back, sort out the 2 front holes and then turn it around. So I really want a reference position for it, and I'm going to set this parallel here, parallel to the back face of this angle plate, to give me that reference thing. And to make that easy to do, I've just got a 1/2 inch bit of straight rod here. We'll set that in there and move the parallel up to it. Just give that a very gentle tap to Okay, so with the angle plate set, I can put this up under here. This angle plate's machined flat both sides. I've got a reference surface at the back to hold it up against. We'll use these T-bolts. Now I think we're getting close to a setup that's going to be possible to use. I'm just going to hold that over. I'm going to tighten this up. Oh, come on. Same on this side. Okay, it's not going to be a very rigid setup, that's for sure. But it's probably going to be good enough for what I need to do. But I still need to probably get a bit of support under this side. Maybe a clamp each side here would get the job done. Let's check that idea out. Okay, so it looks like these little toolmaker clamps will get the job done quite nicely and keep things nice and under control, hopefully. Oh, there's a lump there, so I won't be putting one there. Can't reach in that way. So it looks like I can't particularly support that corner. Okay, well I'll come up with a bit of extra support there. So I think that support holding it up against the underside, combined with the clamp and all the rest of it, for the very light cuts that I'll be taking to mill the clearance on the back here. I only got to do it by a millimetre, maybe 2 millimetres. I think that'll be fine. I guess we'll find out. Okay, so the next thing is to find this hole, the centre of it. And to do that, I'm going to use a centering indicator. So first up, take the wobbler out. Centre finding thing back here. Hopefully I've got enough height for this. I guess we'll find out shortly. As you think about it, I should have used a pointer in the chuck first to get a crude approximation of where it is instead of starting with a precision instrument. That was a bit dumb, so I'll do that. So I'll put the wobbler finder back in there because it's got a nice convenient little point on the bottom, and we'll see if we can use that. Snug it up so it doesn't fall out. Right. Yes, well, we can see we are in fact quite a long way away. So that will be somewhere near it. Much closer than it was before anyway. Let's put this fellow back in now. And where have I put the pointer? There it is. It's got a flat on it that should face the screw. Alright. Let's see how we get on with that. Might work a bit better. So for our first pass, yeah, that's actually pretty close. So unbelievable. Something's just dropped down inside this thing. I have to stop the recorder and fish it out. Alright, I dropped the rod that stops the body of this thing from turning. I'll just put that in there. Use this as an anchor to stop that from rotating. Alright, so now we want to set that on to a slow speed rotation. You can go on back here, I think. Right. Okay. I'll try moving it closer. It's making it worse. Anyway, it's improving it. And that's making it better. And so I don't know how round the hole actually is. That might be about as good as I'm going to get it. I think that jump there has probably got as much to do with the fact that it's just a casting hole rather than a machined hole. So we'll call that good enough. Handy little gadgets these. Alright, so we'll take that out, get our milling cutter in. Alright, now let's see what that looks like. just do a bit of a touch first and see whether it looks like we're in the right place. Okay, so we'll come down, touch, turn the quill DRO on, zero that, and the head of the riv nut thing is 2mm above the surface, so if I come in here, 2, that's the deepest it could possibly need to be. In fact, I'm pretty sure 1 would be enough, because that would still give 1.5mm of squash on the gasket. But I guess whether it's 1 or 2 doesn't matter much, so, or perhaps I'll compromise and do 1.5, eh? Why not? So, right. I think we need to be terribly first. There we go, that. Just check our 0. Yep. And come down 1.5. Well, let's just see what that looks like. Yeah, well, that looks like we're in about the right place. We're coming down 1.5. That's the half. There's 1. This actually looks quite deep. Oh, stick with my 1.5. That's 1.5. Okay, so now I'm going to go that way to check my piece of paper. I think it was 85. We go that way 85, so we'll 0 Y and go in 85. It's 85. Oh, it's not 85, that's the long side. Should be 118 on the long side. This bar is hitting on the back there. Goodness me. Alright, can we get to 118 now? Yeah. Right. Yes, that looks like it's going to be about the right position, just as a crude check. So, hopefully we'll touch at 0 again. Yeah, that matches. And then down 1.5. We can speed it up a bit too, I think. Right. Down 1.5. There's the 1.5. Now, before I take that out, I think I'll clamp something on the back here so I've got a reference mark to put it back to. Now that isn't going to work, is it? I'll have to find the hole again. Yep, I have to find the hole again. Okay, well, we'll see whether the first 2 reliefs worked. I'm pleased to say, yep. That's very good. It's brought it down, allowed it to be right down. So there's going to be plenty of room to squish the gasket down. All right. Set it all up again and do the other side. I said that bit was sharp. It certainly is. I just touched it on the way past and it scored. It is sharp. Yep, I think we'll take that. And put the centre finding indicator away safely. Alright, time for milling cutter to make another entrance. Just make sure that there's nothing on the taper. Okay, she might come up a bit. Get this out of the way now. Doesn't come to any harm. Come up a bit. Right. A bit more. Yeah, that's looking about right. Come down to 0. 0 the quill DRO. Okay, let's go now 1.5 again. Coming out of back gear would help. Right, it's more like it. check my workshop drawing. Got to go 118 this way. Pull it all apart and see if it does what I'm hoping it will. So, bit of an ugly lash up maybe, but looks like it's done the job, or at least if it hasn't, it's just me making mistakes with measuring, which I do have a historical precedent for, I must admit. Americans talk about bozo moments and being visited by Mr. Bozo. In Australia it's more that we think Murphy's got in on the act and blame Murphy if things haven't worked as they're supposed to. Right, well there's our relieved holes. Big question, will it fit? Oh, look at that. A little bit of room all round. Very happy with that. So I can put it all together now and install it. This machining job is done. Okay, so has the machining done the required, given me the required clearance? Let's have a look. Oh, zero that, make sure it's zero, yeah. So the thickness of the boss sticking out above the lid is 1.5, and this rule is 1. So if it won't go in, it means I've crushed the rubber down to by at least 0.5 millimetre. Well, it's not going in there. Adjust that so it just grabs it. No, I'll put a bit of crush on the rubber. Wind this one in a bit. It wouldn't be possible to trap this at 1 millimetre thick if the boss of the rib nut wasn't going up into the recess which I've machined, so it's definitely working on those two. Same here, won't go, oh, just snug, just snug. So clearly I've got the recesses in the right place, and they are covering the and these bosses are going up into them, so I have got a good squash now on that rubber gasket. So that's what we were trying to achieve. Happy with the result. Okay, so here it is, assembled on the test pole. All seems to go together pretty well. So next step is to put it up on its real mast. Call the job done.